This is Knowledge Engineering with Semantic Web Technologies. We have Lecture 2, RDF-based knowledge representation, and in this part of the lecture we want to talk again about SPARQL. And I want to show you that SPARQL is more than just a plain query language. So we know this already, that the SPARQL language has the query component, the protocol layer, and also the output specification. And we want to start today here with the XML output specification format for SPARQL queries. So what the SPARQL endpoint returns to you usually is an XML formatted document or a well-formed XML document where that is structured in the way you see here. So it starts first with a SPARQL namespace, of course, and then within the header of this document, so within the head text, all the variables that have been queried are listed. So then you have variable as a tag, and then attribute name, and then the name is specified of that variable, which is given as a string. So here we have an example for the variables x, hpage, name, mbox, burp, or something like that. Okay, so you know in the header already which variables are used, and then usually there comes a section where you will find all the variable bindings, and this is in the so-called results section. So there is a results tag, and in the results tag all the single results are bundled. So in the results, so this is plural tags, there are single tags called result, where one result line for all the variables then, or one line of the result usually is displayed. You remember SPARQL results always are displayed as tables, so one row of the table then is the same like which is in the result tags. So then in the result tags you will find binding tags, and then for each variable you will find the value, so the binding of that variable. So let's have a look at the bindings. So within the binding, of course, there is the name of the variable, and then it depends on which kind of node, which kind of value is returned. So here, for example, marked red, you see that a blank node, a B node, is returned here. But if you look at the next line, usually a URI can be returned. Then you have a URI tag, or it can be returned a literal, which can be also typed. Then you have the literal tag. So also, so there are lots of possibilities of literals, typed literals, URIs, or blank nodes, which can be returned and then will be specified here within the XML result format. So you see it's pretty simple to pass an answer of a SPARQL endpoint like that. Okay, so much for the simple XML output format specification. Let's have a look at the protocol layer. You know, on top of HTTP, SPARQL as a protocol can be sent from a user interface of a SPARQL endpoint to the SPARQL server endpoint, and there it will be processed and the result will be returned. And we will have a closer look at this process of communication. So on top of HTTP means that I specify a URI, and in this URI, I encode my entire SPARQL query. So I start usually first with the URL of the SPARQL endpoint. So this is a fictive endpoint, so this does not really exist. So I use this here in blue as the basic building block of my SPARQL query. And then, of course, there is a question mark in the URL, which specifies a part where you can specify a query. First thing which comes next is the name of the graph I want to query there at the SPARQL endpoint. This is given here in red. So here I want to query, for example, a single RDF file, which is on that SPARQL endpoint available. And then there comes the SPARQL query given in green. And here, of course, in the SPARQL query, often you have blanks and stuff like that, and you have new lines, and all this usually will be encoded here via URL encoding. Therefore, you see all these interesting ampersand encodings in green within the query. So if you try to translate this then in a usual string without the URL encoding, you will see the SPARQL query. So this then is the query or the URI that has to be sent to the SPARQL server to initiate your SPARQL query. So let's have a look on the SPARQL query in the HTTP trace. So first you see here in the gray box the SPARQL query that we want to question, or that we want to process. So we're selecting authors and works from a graph where we look at graph patterns where we combine authors with their notable work. So pretty simple, and we limit the result to 100. So what we do with HTTP then is simply we send a GET request to the following URI. So the URI again consists of the DBpedia SPARQL endpoint, then the DBpedia graph in red that we want to query, and then comes the query in green. So this is simply the URL encoding of the query you see here above in the gray box that you see here in green. And then in the rest of the HTTP request, you see the host that is queried, which is dbpedia.org. You see the user agent that I am using, and you see what I accept as an answer, which will be text HTML or application XHTML or XML. So this is the HTTP request that is sent directly to the SPARQL server. The SPARQL server processes this request, and then the message that will be returned from DBpedia is here in the blue box given. So this is the HTTP response. You see here it was a positive response. So the server answered with the code 200, which means, yeah, everything is okay. You will get a positive response. Then there is the date when I did this query, and then you see some other header files or header variables that give you some hint about the type, the content type, the content length, and stuff like that, and what was the server I have queried, so what was the server software running there. And then comes, we know this already from the output format, the SPARQL namespace. So SPARQL and namespace definition, and then we see within the header text the two variables that we have asked, author and work, and then we see in the results section the resulting lines, and the first line I have given here, which is the author, and of course this binding is a URI, and you see here the URI of the first author, which is Ding Ling, and you see the most notable work. So this is a work called Miss Sophia's Diary. So in that way the message is returned. So this is the SPARQL protocol, just as an example. You can trace this also on your local machine, and you will see exactly what is going on there in the communication with the SPARQL server. Okay, so these were the two parts of the XML output format specification for SPARQL queries and the protocol layer for SPARQL. Let's return to the SPARQL query language. And the name of the lecture is entitled SPARQL is not only a query language. So besides the select, you also have other possibilities to query a SPARQL endpoint. And we want to have a look at some of them here. So first of all, sometimes possibly you are not really interested in the entire result of a query. You are interested whether there is a result or whether there is not a result. So possibly the select would return too many answers or something like that. So simply you are really only interested in whether it works or it works not. So, and for this you have a specific command in SPARQL, which is ask. So ask instead of select simply delivers you an answer true or false if there is any resulting line or not. And of course it is used like the select statement. Of course you do not need any variables, so you simply have ask, and then you specify from which graph, and then you specify your graph patterns. So here in the example we simply want to know whether there are authors with notable work, and then we say ask from DBpedia where author is of type writer and author has a notable work. So let's query this at the SPARQL endpoint. It's quite easy. We have here a link for that. So here you see the ask query, and I simply click run, and you see, okay, true is the answer, which means there are authors who have a notable work. So ask is instead of select only for checking whether a result exists or not. But you have more possibilities. So, for example, if in your answer or in the SPARQL response there are URIs, sometimes it would be interesting for you to know which information is there available about all the URIs that are returned in your result. And for that, you do not have to you do not have to create a rather complex SPARQL query. It's pretty easy. You can use the so-called describe directive. And describe is used in the same way as select. The only difference is you will not have a table as a return which returns the values of all the variables that are selected. You will get instead an RDF file. So you will get an RDF graph which contains all available information about the returned variables that you have specified in your output. So here we have the same query that we had initially as a select query, but we have it as a describe query. And therefore, all available information of authors who have a notable work will be given back. And to limit this somehow, of course, we limit it to 10 result lines, which means we limit it to 10 authors and works. But nevertheless, the file will be quite large. So I will try to query this on the SPARQL endpoint again. So you see here, that's the describe query with limit 10. So, and the result, as you see here, is a plain RDF graph or RDF file, which is encoded in Turtle. We're starting with prefix definitions for RDF and here also for DBpedia resources. And then we see here, for example, the first author, which is Ding Ling. And you see here, this is a Chinese woman writer, for example. It's also in the class which is called women, or living thing, and it's also in the class which is called 20th century women writers and stuff like that. So all information about Ding Ling, the first author of our list, is given here. And you see, yeah, there is lots of information. So the first 10 lines of the result of the SPARQL query provide much more information that is given here in the describe answer. So this is the describe directive. What else can I do with SPARQL? So besides the describe, I also have the construct directive. What does that do? With construct, I am able to construct a new RDF graph, which is formed after a template that I specify. So in a template, I specify a specific graph pattern with variables and also with URIs that I can specify there. And the result then will be given in the form of that graph pattern, of that RDF file following that graph pattern. So let's look at an example. So what I do here is, again, we want to select all writers and their notable work, and we want to create new RDF triples which follow the following template, which is given here after the construct statement. And you see here after construct, we have curly braces, and within the curly braces, I specify my graph pattern. And here I put in the variable author, which is specified later on also in the where statement in the graph patterns. And then I say, okay, after author, I want to have a new property, which I specify here via URI. So I give the URI of the has written property from a namespace, which is called example.org. And then I want to have as an object, of course, the work, the notable work. So besides that the author has a specific notable work, we want to state here in the triple that the author has written that work. So let's try it out. So here again is the construct SPARQL query, and we run the query, and you see here also the query was limited to 10 results. We see here in the end we have a new RDF file that is again encoded in Turtle. So we have two namespace prefixes, one for example.org, one for DBpedia resources. And we see here that the first author, Ding Ling, has written, and then here this book called Miss Sophia's Diary. So this was a SPARQL construct query. So besides select, just as a summary, we have several possibilities to generate interesting SPARQL answers. First one is ask, simply to ask whether an answer exists or not. And the second one then is describe, where we have the possibility to describe all URIs that are returned in the response of a SPARQL query as a variable value. And in the last place, we also have the construct directive, with which we are able to construct new patterns, new graph patterns. And this, of course, can, for example, be used to translate one RDF vocabulary into another RDF vocabulary as we did here. So here we substituted a property which stemmed originally from the DBpedia ontology with a property that comes from another vocabulary that we have specified here in the graph pattern. So the construct query can be used to transform RDF graphs from one vocabulary into another vocabulary. Okay, and in the next part of the lecture, we want to have again a look at the select SPARQL queries, and we want to have a look at more complex SPARQL queries.